everybody. Welcome to another episode of What's Next from IBM. I'm your host, PJ Haggerty, and today we're talking to Abby Mitchell from IBM Quantum. Abby, tell us a little bit about IBM Quantum and what you're up to.
Sure. So IBM Quantum is a small department within IBM. We actually are part of the research organization. And essentially what we do is we build quantum computers. If you don't know what a quantum computer is, we do not have time to go into that much detail.
There's documentation. We can link that in the show notes.
We'll link
Not
you
a
some
problem.
documentation. But essentially you can think of it as sort of the next generation of supercomputer. And we're sort of pushing towards this future goal of having, quantum processing units, QPUs that can be integrated with GPUs and CPUs to perform very advanced computation. So IBM Quantum as a department, we focus on building the hardware as well as all the cloud infrastructure, all the way up to the top of the stack where we have an open source SDK where you can write Python code to actually interface with these devices.
That's the part that excites me the most. And how do you, because quantum is kind of a hard concept to grasp if you're not familiar with it. How do you kind of encourage people to get involved with IBM Quantum?
We put a lot of effort into enablement and education, developer relations. We try to create as much online content as we can to sort of reach as many people globally as possible. We have a learning platform, which we'll link in the description, also documentation, a YouTube channel, and we also run a ton of events throughout the year. So we have big virtual events with thousands of people, and we also just recently hosted an in-person event where we invited, called the Quantum Developer Conference, where we invited about 200 of our most advanced Qiskit users to come to New York, see the lab, see the real quantum computers, practice using the tools. So in general, we do like a mixture of online enablement and some in-person events as well, and anything we can to try to get people to know more about how to use these things.
That is super awesome. Now you mentioned Qiskit, which is a word that, as you know, I've been trying to practice as much as possible before we do this. What is Qiskit? Like, how does it work for developers?
So the term Qiskit actually is a bit more of an umbrella term for a lot of different software packages that IBM Quantum develops in-house. The core of this whole sort of ecosystem is the Qiskit SDK. That is the open source interface. It's a Python-based interface where you can essentially write Python code and build up quantum programs that can then get sent through the cloud to actually be run on a real device. And then you also have a few other software packages that are also under that Qiskit umbrella, such as Qiskit Runtime. That is the interface for sending things through the cloud. That is the runtime. We also have additional packages like a transpiler service, various different AI enhanced packages as well. But the real sort of like core package is that open source SDK. If you're just getting started, that's the one that you're going to start with.
Awesome. And how easy is it, or not how easy? Well, I mean, yeah, how easy is it to get started with like Quantum and Qiskit and everything in between? Because I know that one of the biggest things I look at as a developer advocate, but also as a developer, is just like, all right, so this is really interesting and I'm super into it, but like I don't know where to start and everything's like way over my head. What's like the easy on-ramp?
Well, I would say definitely you should prepare yourself for a steep learning curve. There's definitely some small examples you can get started with to just sort of play around with the concepts, and there's definitely many tutorials out there or YouTube videos that will sort of get you that, like, you're just dipping your toes into it. But very quickly you're going to find that if you want to actually start doing like really cool things with quantum devices, you're going to need to upskill a lot in some quantum theory, some classical computing concepts. I would really recommend going to, I know I'm like shilling our own like learning platform again, but like
it's okay. That's what we do.
That's why we're here. If you go to learning.quantum.ibm.com, that I would say is the best sort of first getting started in this world. And I would definitely recommend, there's a great course by Dr. John Watrous on understanding quantum information. That's probably the best like starting course. It does start you in on the theory, and you don't necessarily get to the real coding part until a little bit later. But at a certain point, even when you're just playing around with the code, you're going to find that you're going to need to go back to get that theoretical foundation in order to progress beyond that. So that's my recommendation.
And sometimes I found that sometimes that's the best way to kind of interact with machines in general, is like, if you don't understand why it's doing or not doing the thing you want it to do, maybe take a step back and look at how we build these things. Like, why are we building these things? What do they do?
And I think people get a bit put off because they get confronted with like all this linear algebra and these like quantum concepts. They're like, oh my God, I can't do it. But I think if you can push through that, and if you prepare yourself that like this is not an easy topic, this is challenging, but I think it's definitely worth it if that's something that you're passionate about, and it's worth like taking the time to really dig into it.
Absolutely. So what can we expect in the near future, or even the far future, from like Qiskit and the IBM Quantum team?
So much. We are so busy all the time doing all the things. I'd say like big things coming up next year is the Qiskit SDK is going to have its 2.0 release at the beginning of next year. And so with that release, we're going to have a lot of performance improvements. We've actually been rewriting the internals of the SDK. It's still a Python interface, but a lot of the internals are being rewritten in Rust. So this is really sort of driving towards this, a really big push on performance. Like we want to make sure that SDK is really, really performant, because when we're scaling our quantum devices up to needing like hundreds and hundreds of qubits, you're going to need that SDK to be able to compile those circuits quickly enough on a really large scale. So the software performance is something that we're really pushing forward at the moment. So definitely keep an eye out for that. Other than that, every year our devices get better and better as well. We either improve like in terms of pure numbers of qubits, there'll be more coming, but also the quality of the qubits is really important. So even if we're not necessarily increasing the sheer number of qubits, we're definitely improving the quality and how accurate they are. And then the software that goes on top of that, the speed aspect of it, like how many computations can we run on a single qubit in the time? Because these qubits don't live very long. Yeah, there's many different aspects that it's all about performance, from the software down to the hardware. That's a really big push for us in the next year for sure.
That is awesome. That's exciting. I'm looking forward to it. Abby, thank you so much for sitting down to talk to us here on What's New.
Thank you for having me.
For everybody paying attention and watching, we will have all those links for you, and we'll see you next time on What's New. And thank you so much to the IBM Quantum team, and we'll see you next time.